Okay? So we're not sure. That one inequality sign can't tell me all that. Okay? So what you're going to do is you're going to pick any number on the left-hand side of -3. We're going to test it. Pick a number that's less than -3. -4. Pick a number, any number between -3 and 7. 2. Let me tell you this. We're going to have to plug these numbers in. So you could pick, be wise about your picks. 2 would work, but what number would be easier to plug in for x between -3 and 7? 0. Okay? If you want to plug in 2, as long as it's a number between -3 and 7, you can plug in 2. And then what would be a third point that we would pick to test? Anything bigger than 7. So somebody said 8. Okay? Where are we plugging these numbers in? We're plugging these numbers back into the original problem. Okay? So what our original problem says is that whatever x is plus 3 times whatever x is minus 7 must be less than or equal to 0. If it is, then we know that's a solution area, and we get to shade all the numbers in that area. So if we do -4, okay, again, don't overuse your calculator here. If we do -4, -4 plus 3 is -1. -4 minus 7 is -11. Is that going to be less than or equal to 0? True or false? That's going to be false, because that's going to be a negative times a negative, which is a positive 11. So that's going to be false. So what that means is we don't have any solutions to the left of -3. So we can't shade to the left of -3. So -4 did not test out to be true. So if -4 doesn't test, then neither does -5 or -10 or -27. Y'all get me? So we can't shade to the left of -3. So let's try 0. 0 will be easier. 0 plus 3 is 3. 0 minus 7 is -7. And if you don't want to write your test down, you know, like all this little work, I do want you to write x equals -4, x equals 0, x equals 8. So 3 times -7, will that be less than or equal to 0? Yes, that's true, right? All right, so that means you get to shade, because 0 is between -3 and 7, you get to shade everything between -3 and 7. So our testing is telling us where we shade. So let's pick a number. We picked 8. So that's going to be 8 plus 3, which is 11, times 8 minus 7, which is 1. Is that 11 times 1 going to be less than or equal to 0? True or false? False. That means we can't shade to the right of 7. So our solutions to our original problem are any numbers between -3 and +7, including -3 and +7. So then they want you to write all those solutions that you've shaded in interval notation. So how would I write all the solutions that we've shaded in interval notation? Bracket, -3 all the way to 7, bracket. Those are all your solutions. It's a bunch of solutions. Decimals, fractions, whole numbers. All the numbers from -3 all the way to +7 are the solutions to that polynomial inequality. Questions about example 1? All right, example 2. Solve the polynomial inequality. Write your answer in interval notation. So this time the problem won't be factored for us. This time the problem will not be factored for us. So before we factor, we have to make sure that one side is equal to what? 0. So we'll take that -4 and we'll bring it over to the left-hand side, and it will become +4. Before we factor, one side of our inequality has to be 0. Okay, that's a trinomial, right? So trinomials factor into 2 binomials. Are the signs going to be the same, or are they going to be different? They're the same, and they're both positive. Is this an easy trinomial or a hard trinomial? Easy. So what multiplies to be 4 that combines to be 5? 4 and 1 or 1 and 4, it won't matter. Take each factor, set each factor equal to 0, and solve for x. What two x's do you get? -4 and -1. Draw your number line. Which one must go to the left? -4. Which one must go to the right? Open or closed at -4 and -1? Open. Okay, now we have to figure out where we're going to shade. And to figure out where we're going to shade, we have to test. Give me some numbers that we're going to test. -5, -2, 0. Anybody not know where we're getting our testing numbers? All right. You need to go into the original problem. Anytime you've altered the problem, there's a chance that you have changed it incorrectly. So always go back to your original problem to test. So in the original problem, if we do -5, -5 squared is 25. And then we have plus 5 times -5, that's a -25. And we're checking to see if that's greater than -4. Is 25 minus 25 greater than -4? Yes, because that would be 0 is greater than -4. So that one would be a true. So that means we get to shade everything to the left of -4 because the number that was to the left of -4 that we tested was true. All right, let's check -2. -2 squared in the original problem is 4 plus 5 times -2, that's -10. And we're checking to see if that's greater than -4. Is 4 minus 10 greater than -4? No, it's not, because that's -6 is greater than -4. That's a false statement. 0 is going to be easy. 0 squared plus 5 times 0 is 0. And we're checking to see if 0 is greater than -4. Is 0 greater than -4? It is. So since 0 checked, we can shade all of the points where the 0 would be. And that would be to the right of -1. So we didn't shade in the middle here. We shaded on both sides. So we're going to use two intervals. So our smallest interval will go from -infinity to -4, parentheses, because the circle is open, union, parentheses, -1, all the way to positive infinity. All right. So how do you think these problems can get harder after just seeing two of them? If they don't easily factor. Okay. So let's look at one that I think that you might struggle with factoring a little bit. So if the factoring got a little bit difficult. So let's look at example 3. And this is just one that I think it doesn't look very hard to begin with, but y'all might have trouble factoring it. And you wouldn't think this one was hard because it's actually got less terms. It's not a trinomial, it's a binomial, but I can just tell you by experience, a lot of students struggle with this. So the right-hand side is already set equal to 0, which is good. How would you factor the left-hand side? Take out a -x. That's called a GCF. And what are you left with after you take out a -x? X what? X minus 1. So you may be confused about that. Alright, so when we go to set up our little equations here, I know everybody understands that x minus 1 is equal to 0, right? But what do you do with the x? What do you do with the negative? The negative actually doesn't matter at all. Okay, so if you had a GCF of a 3 or if you had a GCF of a 4, it doesn't matter. You're just going to take your factors. Y'all remember when we did x-intercepts? We didn't care about any factor that did not have an x in it. So that -1 really doesn't have anything to do with the solutions. Okay, so you can just take just the x and set it equal to 0. So we got x is equal to 0, and we got x is equal to 1. And I think the rest of this y'all could do, but we'll go ahead and do it real quick. So we'll put those numbers on the number line in order, smallest to largest, open or closed. Closed. And then we've got to figure out where we're going to shade. So give me some numbers that we're going to test. -1. A half, or 0.5. 2. Y'all good with those? Do you have to pick -1 and 0.5 and 2? Do those have to be the numbers that you pick? No, you just can pick any number to the left of 0, any number between 0 and 1, any number to the right of 1, whatever makes you happy. Okay? You're going to go back into the original problem. Got to be a little careful here when you plug back in. So you got to do order of operations. So when you put that -1 into the x squared, you got to do -1 squared, which is +1, but the negative makes it a -1, and then you got to add -1, so that gives you -2. Did I lose anybody there? When you put the -1 into the x squared, you get +1, but the negative on the outside makes it a -1, plus another x, which is -1, that gives you -2. Is that true or false? True? False. Just checking. All right, 0.5. Y'all might have to do that one in your calculator. I can't do 0.5. 0.5 squared is some number. Then make it negative. And then add 0.5 and tell me what that is. 0. What? 0.75? Is that going to be greater than or equal to 0? True or false? True. All right, if x is 2, 2 squared is 4. The negative makes it a -4. -4 plus another 2 is a -2 is -2 greater than or equal to 0, true or false? That is false. So where are we going to shade? In between. And how do we write all those solutions that we just shaded in interval notation? Bracket 0, 2, 1, bracket. Okay? So you could get a few problems that are a little bit harder to factor. All right, this is what else happens. Okay? This is in the, now this one's going to already be factored. Everybody got 3? All right, this example's already going to be factored, but it's going to have more than 2 factors. So that could also happen. So here we're going to have x plus 1 is already factored, and then you have a factor of x plus 2, and then you have a factor of x plus 3. So you could have something that factors into more than 2 factors. So our first 4 examples all had 2 factors. So here's a problem that's already been factored for you. That's good. The other side is 0. That's good. So these are not very hard to solve. So can y'all just solve in your head and tell me what you're getting for your x's? This is example 4. Thank you. I'm skipping some examples for y'all not to make this so long. Sorry. I skipped an example on purpose. Okay. So make a number line. You can start to walk me through this because I've kind of taught you the basics now. What do we do next? All right, and I don't care that they're spaced out equally. If these numbers weren't the same distance apart, doesn't matter. Just make sure they're in order from the smallest to the largest. It really won't matter once you get your ending answer. What do we do next? All the circles are closed. All right, y'all know why this one's going to take longer? You have to test 4 numbers because there's 4 different areas that you could shade. Okay? You're going to test 4 numbers here. So in order to shade, we have to test And going from left to right, give me four numbers that we can use to test. I've already got it worked out, so y'all just want me to tell you what I picked? Okay, I think y'all know what we're doing. I picked -4. I picked -2.5. I picked -1.5. And I picked 0. Do those make sense to you? Okay. Do you want me to show you how to plug those in, or do y'all understand? You'll have to plug the x in 3 times. You have to do -4 plus 1. And you have to do -4 plus 2. You have to do -4 plus 3. You have to get those 3 numbers and multiply them together to see if they're greater than or equal to 0. Do you see how you would plug them in? Okay. So for this one, I got false, true, false, true. False, true, false, true. But you would plug them in just like we did before. It's just going to be a little bit more work. Okay? So where are we going to shade according to our falses and our trues? Between -3 and -2, and on the right-hand side of -1, which would include the positive infinity era. Then you would make a list of all your solutions. So that would be 2 intervals of solutions. What's the smallest interval? Bracket -3 to -2, bracket, union, bracket, what's the last interval? -1 to positive infinity. All right. Got 2 more examples. Can y'all make it? All right, 2 more. All right, since that's maybe not. Okay, example 5. So there's an underlying theme in this whole little section, and it's factoring. You're going to have to, if the problem's not factored, then you're going to have to factor it. You're going to have one side set equal to 0. So we have to factor the left-hand side. And because there's 4 terms, what is that? The clue that what type of factoring we're going to do. We're going to do grouping, and we usually group the first 2 terms and the last 2 terms. What's the GCF between the first 2 terms? X squared, and what do I get when I factor out an x squared? X plus 1. So that means my other group needs to also be x plus 1. What can you factor out of 4x plus 4 that gives you x plus 1? A plus 4. Then you factor out your group, and that leaves you with x squared plus 4. X plus 1 times x squared plus 4. Again, we've done this before. This one has a little something kind of crazy happen. So you set the x plus 1 equal to 0. That's no problem. If x plus 1 equals to 0, x is equal to -1. But if you set x squared plus 4 equal to 0, then x squared plus 4 won't factor, so you have to move the 4 over. It becomes negative, and then once you take the square root of both sides, you get plus or minus what? 2i. Okay? And plus or minus 2i is 2 imaginary solutions. Well, we don't graph imaginary numbers. Okay? Our number line is real. We can't graph imaginary numbers on a real number line. So because you got 2 imaginary numbers here, you need to know when you go to put things on your number line, the only thing you can put on your number line is a -1. Imaginary numbers do not go on a real number line. Okay? So, however you want to put that, can't go on real number line. And then when you go to decide where you're going to shade and you test, you only have to test two numbers. Pick me two numbers to test. -2 and 0. We're testing back into the original problem. You might have to get your calculator to help you out here. -2 cubed is -8. -2 squared is +4. 4 times -2 is -8. And then we have +4, and we're checking to see if that's greater than 0. Is that going to be greater than 0? -8 plus 4 minus 8 plus 4. Is that going to be greater than 0? Nope. So that one's false. 0 might be easier. 0 squared, cube plus 0 squared plus 4 times 0 plus 4 is 4 greater than 0? True. Oh, we forgot. Open or closed at -1? Open. And then the only point that tested was the 0, and 0 is to the right of -1. So we would shade there. And our answers would be parentheses -1 to infinity. So I wanted to show you what happened if you solved and you got some imaginary x's. We just can't put imaginary x's on our real number line. Can't put imaginary x's on our real number line. All right, last example. Any questions about example 5? Now I have a note that says directions are written different, but work them exactly the same. That's really good English, and I know with my southern accent that sounds really good. It says directions are written differently for my next example. Okay, so for example 6, how about I just read you the directions? The directions for this type of problem are going to be a little bit different. It says solve each rational inequality and graph the solution set on a real number line. Express each solution set. I think I'm trying to, the directions change, but you're still going to solve it exactly. You have two sets of directions. Solve each polynomial inequality and graph the solution set on a real number line. Express each solution in set builder in solution set in interval notation. And then this example that I'm going to do right now, the directions say solve each rational inequality and graph the solution set on a real number line. Express each solution set in interval notation. So the directions are, it's a different set of directions, but they're really saying the same thing. So we're just going to do the same type of thing. What's going to happen here is because they say rational, that means you're going to have an x in the denominator. You're going to have an x in the denominator. Thank you. Alright, so y'all see the big difference here is you have that x plus 3 in the denominator. Okay, so that means you have an excluded value. So what can x not be? X cannot be -3. So on your number line, you're going to have -3 on your number line just because that really means if we graph this problem, that we would have a vertical asymptote at -3. So x cannot be -3. So we're going to have to put -3 on our number line just because x equals -3 is an excluded value. Okay? So however you want to make a note of that. So we know that x can't be -3, so there'll be an open circle at -3 on your number line when we get to that part. Okay? Then you're going to kind of just ignore the x plus 3, and you're going to pretend that the problem just says x minus 4 is greater than 0. Okay? And then you'll just take the x minus 4, and you'll set that equal to 0, and you'll get x is equal to 4. So the two numbers that are going to go on your number line are going to be -3 and 4. Okay. Negative 3 is open. Okay. Negative 3 is open because it is an excluded value. 4 is open because there is not an equal to on the original inequality. So 4 could possibly be closed if it would have been greater than or less than or equal to. But the negative 3 will always be open because it's an excluded value. The other numbers could be open or closed based on the inequality sign. Alright, and then we're going to test 3 numbers. And to help y'all out, I tested negative 4, I tested 0, and I tested positive 5. Now I'm going to show you my work for the test because you have x's in the top and the bottom just so you know how to do this. So for negative 4, you'll go into the top. Negative 4 minus 4 will be negative 8. You'll go into the bottom. There's another x. Negative 4 plus 3 is negative 1. And we're checking to see if negative 8 divided by negative 1 is greater than 0. True or false? That's true. I don't usually work it all out. I get enough written there so I can just look at it just so I don't have to write everything out. If x is 0, what do I get on the top? Negative 4, what do I get on the bottom? Plus 3. Is negative 4/3 greater than 0? No, it's not. If x is 5, 5 minus 4 is 1. 5 plus 3 is 8. Is 1 over 8 greater than 0? Yes, it is. So I'm going to shade in 2 areas. I'm going to shade all the numbers less than negative 3, all the numbers greater than 4, and then I'll write my solutions in interval notation. So it'll be negative infinity to negative 3, parentheses, union, parentheses, 4 to positive infinity. Alright, I'm going to show you one thing, but I'm not going to work it all out. I know y'all are thinking you just said 2 more. Let me think for just a second. Okay, I'm going to set up 7, but I won't solve it completely. And I want to show you 7 because it's not set equal to 0. The book really has a long, drawn-out way to do this one, but I have a shortcut, okay? So I just kind of want to show you the shortcut here. First of all, because you have an x in the bottom, what can x not be? Okay, x cannot be negative 2. So on your number line, you'll have an open circle at negative 2, okay? You don't have to factor these. If you will just take the problem, once you do your excluded value, if you'll just take the problem just like it is a proportion, if you'll take the problem just like it's a proportion, because it's equal to 2 here, because the 2 is on the right-hand side, I'm showing you a shortcut here. So you can't just take the top and set it equal to 0 because there's not a 0 here on the right-hand side. So once you do your excluded value, think of that less than or equal to as an equal to, and you have a nice little proportion, and then you can cross multiply. That's going to give you 2x plus 4 is equal to x minus 2. And then you'll solve that equation for x, and you'll get x is equal to negative 6. So on the problems that don't have a 0 on the right-hand side in the section where you have the x's in the denominator, you'll do the excluded value, you'll pretend that the inequality sign is an equal sign, you'll cross multiply and solve. So the 2 numbers that are going to go on your number line are negative 6 and negative 2. Open or closed at negative 6? Closed. Why closed? Because that circle goes back to the original sign, and it's less than or equal to. Negative 2, open or closed? Open. Why? It's an excluded value. And then you're going to test, yada, yada, yada. And I'm just going to show you on this one, you're going to end up shading on these 2 sides. You would test the same way. This one's just a little bit different. The book makes you move the 2 over, find a common denominator, and it creates this horribly long problem, but this way works every single time. Okay, and then you would write your intervals. We're not going to do that anymore.